Good morning, champs. Today we are going to identify all of the zero force members in a much larger truss. We will not calculate the support reactions, and we will not calculate any of the remaining member forces. The goal is simply to apply the three zero force member rules systematically. Before beginning, let us quickly review those three rules. The first rule applies to an unloaded joint where only two non-collinear members meet. Both members must carry zero force. The second rule applies when two members meet at a joint and an external force acts exactly along one of those members. The other member must carry zero force. The third rule applies at an unloaded joint where three members meet and two are collinear. The third, non-collinear member must carry zero force. For a small truss, we can sometimes spot these members immediately. For a larger truss like this one, I recommend something more systematic. Start at one end and inspect every joint individually. We begin at the lower left support joint. Several members and the support reactions meet here, so none of our three rules can be applied directly. We simply move to the next joint. Now consider the upper left joint. Two members meet here. One is vertical and one is horizontal. An external horizontal force also acts at this joint, exactly along the horizontal member. This is our second rule. The horizontal member can balance the external force. In the vertical direction, only the vertical member could contribute. Since there is nothing for it to balance, its force must be zero. Therefore, member C is our first zero force member. We continue to the next joints. At the joint carrying the first downward load, several member forces and an external force are present, so none of the simple zero force rules apply. At the lower joint beside it, several members also meet, so again we cannot immediately identify another zero force member. Now we arrive at the middle lower joint. Three members meet here. The two horizontal members lie on the same straight line, while the third member is vertical. No external load acts at this joint. This is exactly the third rule. The two horizontal members can balance each other, while the vertical member has nothing to balance it. Therefore, member 1 is a zero force member. We keep moving through the structure. At the joint carrying the second downward load, the simple rules do not apply. The neighboring joints also contain too many relevant member forces to identify another zero force member immediately. This is why checking the truss systematically is important. We do not stop simply because we have already found two members. Eventually, we reach the upper right corner joint. Only two members meet at this joint. One is horizontal and the other is vertical. They are non-collinear and no external load acts at the joint. This is our first rule. Equilibrium is only possible if both member forces are zero. Therefore, members N and O are both zero force members. Finally, we check the right support joint. Because a support reaction acts there together with several members, none of the simple rules produces another zero force member. We have now inspected the complete truss. Without calculating a single support reaction or solving a single member force, we identified four zero force members. These are members C, I, N, and O. The main lesson from this example is the importance of a systematic approach. On a small truss, zero force members may be obvious. On a large truss, start at one end and inspect every joint using all three rules. Mark any zero force members you find. Continue through the complete structure and check the joints again if necessary. This simple habit can remove several unknowns before the actual truss analysis even begins.